My name is Edgar Pedresa, and in this video I'll be covering what is a USF file. And here's our area of focus. So if you refer back to our terminology video, we refer to a USF file as a text file, which gets exported from the takeoff program and has a lot of important information like part numbers, cut sizes, LDTs, and their location. But in this video, I'll be going a little more in depth with what a USF file is, and I'll be bringing in a DM USF file and a Quadra USF file and comparing them a little bit and describing the important information on each text file. And of course, showing you how to read it. But just as a note, the reason I'm only describing the two USF files, Quadra and Diema, is because the satellite and the planet are just like the Quadra. Those three get outputted with an optimization, unlike the Diema USF file. So it's changes it a little bit on how it gets exported, but let's go ahead and just get started. And we're going to go ahead and start with the Diema USF file. So as you can see here, we have this W755263 as our example. And the first line of text on every USF file is going to start with the job name. So here we have Van's headquarters as our example. And then the date on here is the date this USF file got exported. And then moving on to the next line of text is the part information. So here we have a W75 system, and it's a 5263. And then we have the finish, so it's paint, and then a description of the part. So it's a 2 3/4 Inviso vertical, and it's a female. And then the next line of text is the piece. So this is the mark number for this piece, the quantity, and the cut size and metric, and then the degree cut on each end. So it's 90 on one side and 90 on the other. And then after the piece, you have the machining. And that's what the M here stands for, the start of all of our machining. So we have this machining 5263, hole 2. And then we have this position for it. So we have this X position and this Y position. And that gives us a location of where this LGT is located on this piece here. So if we were to move on to the next one, so here's the next set of machining. So this 5263, 6875 access H2. And then we have the position for that LDT, X and Y, on that piece. And it's important to note, every machining that has an X semicolon after, that gives us an X position or Y position, is a set of relative LDTs. If we had an absolute, like here, it just has the M semicolon and then a name, and then moves on to the next set of machining. That's another absolute machining here. But if we were to go back, so after the piece, every set of M and X machining and position after it until you reached the next P, all these are all tied to this set of this piece here. And then it'll jump into the next piece, and then all those machinings would be tied to this piece here. So let's go ahead and move on to the Quadra. So just like the Diema, it starts off with the job name, so Van's headquarters again, and then the date this USF was created. And then we're just going to go ahead and jump down to the part here. So we have this W75, and this piece is a 5262. And then the finish for this piece is charcoal. And then the description, just like the Diema. But unlike the Diema, this Quadra has this B right before we get to the part. So this is the bar. So I'm going to go ahead and pull up a optimization report, and this will help us to know what these numbers here stand for. So bar 1 So that first B, or the first number after the B, is the number here, as you can see here on the blue box. And then the second number is 1, which is the mullion. And then the third is the length. So that's in metric over here on the USF file, but then in inches over here on the optimization report here. And then the 1 and then the zeros are the in-swing and out-swing cut. They're already preset in the takeoff program. And then we're going to move on to the piece. So from here on out, it's just like the diamma. We have the piece. So here's the mark number for this piece, the quantity, the cut size, and the angle cut on each end. And then we have the machining again. So here we have this LDT and this position. And then here we have the absolute LDT for this piece here. So we have this absolute here and this other absolute here. And then the start of the next piece. And as you can see here, starting from this piece, going all the way down to this last set of machining, all these are all tied to this one bar. So as you can see over here, this SV2-15A and SV2-10 are all on this one bar. And you can see over here, if we look for the P's, SV2-10, same as over here, and then SV2-15A is the same as over here. So these are all tied to this one bar, which is tied to this here. And then if we go to the next bar, so B2 down here, we could see that this bar 2 is just going to contain this SV2-10. But as you can see on this SV2-10, it just shows a quantity of 1. So unlike the diamma where it shows multiple quantities, this SV2-10 could repeat just like it did over here, depending on the optimization on here and what bar it lands on. So that's the biggest difference between the diamma and the Quadra, is just how it's run by the optimization. Other than that, you can read it the same way, and this basically concludes what is a USF file. Thank you for watching.